Recording in progress.
Hello and welcome. I am Dr. Pauline Fu. In this video, I will demonstrate Monte Carlo simulation using Excel. We are going to go over two questions. Question 1, every home football game for the past years at Eastern State University has been sold out. The revenues from ticket sales are significant, but the sale of food, beverages, and souvenirs have contributed greatly to the overall profitability of the football program. One particular souvenir is the football program for each game. The number of programs sold at each game is described by the following probability distribution. Okay. So this is the number of programs sold. The unit is in 100, and this is the probability. Historically, Eastern has never sold fewer than 2,300 programs or more than 2,700 programs at one game. Each program costs 80 cents to produce and sell for $2. All programs that are not sold are donated to a recycling center and do not produce any revenue. And we are asked to compute 5 questions. Question A, with the historical distribution, what is the expected value? Question B, generating random values from distributions using RAD function in Excel. Question C, simulate sales of programs at 10 football games. Question D, if university decide to print 2,500 programs for each game, what would be the average profit for the 10 games simulated in part B? And then question E, if the university decide to print 2,600 programs for each game, what would be the average profit for the 10 games? So this is the question, and the data file required. So this is the data file. So basically, the data, basic data is given, and you just need to fill out all the blanks here. Fill out all the blanks, okay, based on the descriptions. So let's do one by one. This is the number of demand. This is the frequencies. These data are given. So now we need to calculate what is the probability of for the demand 23. Okay. So the probability equal to frequency divided by total number of frequency. And this number will be absolute cell reference. This 100 because it is the same number for every demand. The 100, this number does not change. Okay. So press enter key. After that, you use fill handle, okay, to drag it down. You get the probability for other demand. After that, there is no number here. You need to figure out. Okay. So what is we figured out the probability. Next, what is the cumulative probability? The cumulative is the first one is the first probability. And then the second one is the previous two probability. So equal sum of these two probability. Again, cell C6 needs to be absolute cell reference. Oops. Equal sum. The first two numbers add together, that is the cumulative probability. But I need to modify the formula so that it should be $C. Oops, no, should be C6, then C7. This one should be absolute. I'm using iPad, absolute cell reference. After that, it is a C7. Okay, I modified the formula so that cell C6 is the absolute cell reference because I want to copy down the formula. Okay, copy down the formula. Okay, and once you have this cumulative probability, this actually served as the upper limit. So we copy data from here to here, Control C, and paste it here, Control V. Value only, paste special. Okay. Just paste value. Okay, you get here, and oops. And then you add 0 in the first limit here. Okay. So this way we produce this one actually the lower limit. This is the upper limit. Upper limit. So you created the range. For example, the demand from the probability from 0 to 0.15, the demand is 23. When probability is 0.15 to 0.37, the demand is 24, etc. Okay. So that is this table here. Now fill out the expected value. Expected value, it is just x times px. Okay. So this is the x frequency times probability of frequency, B6 times C6. And then do the same thing for other cells. Okay. So we fill out this expected value. Next, we want to generate random numbers between 0 and 1 to simulate 10 games. There are 10 games we need to simulate, okay? So in Excel, you type in equal RAND, opening, closing bracket. That is the random number between 0 and 1. Oops. So equal RAND, opening, closing bracket. And then use fill handle to fill down. So once you have this random number, we need to know what is the demand. And for demand, we are going to use VLOOKUP. So this is the probability. We need to look up this value. This value belongs to, for example, belong to here. Okay, this probability belong to 0.15, 0.37. We hope to get 24 in demand. So we need to use VLOOKUP equal VLOOKUP. Open VLOOKUP, opening bracket. So the number we are looking up is this number. Table array, this is the table we are looking for. And this should be absolute cell reference. Command D if you are using Mac. And then column number, we are focused on the third column of this table. So typing number 3, okay, and then typing 1, true, means roughly approximately match. If it is 0, it is an exact match. Okay. So we get number 26 because based on this random number 0.69, 0.69 between here, you see, that's why you got 26. Okay. So once you got 26, you drag it down to get other demand. So this is the demand. And for the cost, it is just, remember what is the cost per unit. 1 unit, it costs 80 cents. And how many units? 2,500 units. Okay. And we are going to use absolute sale reference. Oh, not here. This one. Absolute sale reference for those sale reference. So this is the cost. Okay. And then you drag it down. And the next is the revenue. Okay. For the revenue, we need to figure, remember revenue equal to demand times sale price. But the demand number here, some number is greater than 25. See, this is 27. We only print 2,500. If you have demand 2,700, it is not realistic. So we need to use if function. If the demand is smaller than 25, we use the demand number here in this column. If the demand is greater or equal to, if the demand is smaller or equal to 25, we use the number here. If the demand is greater 25, we assume it is 25 because this is the fixed number you produced. Okay. So once we figure out this, the demand, okay, and then we times sale price, that is our revenue. Okay. So I'm going to use if function to determine demand. So if this number smaller equal to 25, the demand is just this number. Otherwise, we should use 25. If demand greater than 25, use 25. Okay. So the result of this if function is number of demand. So number of demand times sale price is the revenue. Remember number of demand, the unit is in 100, so we have to type in 100 here. So this is the revenue for the first one, and this one is the formula here. Now copy down the formula. Okay. Last one, figure out what is the profit. Profit equal to revenue minus cost. So that is an easy job, equal to revenue. E17 minus cost, D17. And then use fair handle. So that is question 1. Okay, question 1. Now, question 2. Suppose the sale of football games described by the probability distribution. Only 2 days when the weather is good. When poor weather occurs on the day of a football game, the crowd that attends the game is only half of capacity. When this occurs, the cells of programs decreases. The total cells are given in the following table. So when it is good day, you have demand here. And this is the probability. When it is the bad day, the demand is here. And this is the probability. Programs must be printed 2 days prior to game day. The university is trying to establish a policy for determining the number of programs to print based on weather forecast. So part A, if the forecast is for 20% chance of bad weather, simulate the weather for 10 games with this forecast. 2, simulate the demand for programs at 10 games in which the weather is bad. C, suppose there is a 20% chance of bad weather. The university has decided to print 2,500 programs, simulate the total profits that would be achieved for 10 football games. So that is the question, and the worksheet we are going to use is the next one, football weather. Again, basic data is given. You just need to fill out all the blank area, fill out this one, fill out this one, fill out this one. Okay, and all the way here. So fill out those blanks. Okay, the basic number is already given here. Okay. All right, so let's do this one. So first we start from here, the cumulative probability. So this one equal to D6, and the next one equal to sum of previous probability. Okay, and then you have to modify the formula for the D6 to absolute cell reference. So type in $D, $6. The purpose of using absolute, you want to copy down the formula. You want to copy down the formula. And then you create the lower limit. It is just from here to here. That is the lower limit. So copy. And then paste. Paste special. Just paste the value. By the way, I'm using iPad Pro to do this demonstration, okay? Maybe the case chalk is different when you use a PC. So now add 0 here. Okay, so we completed this form. And similarly, this is for good weather. Now let's do the bad weather. This is the probability. This time I will do a little bit different. So lower bound, I will start with 0. And then I use the sum of these two numbers. And then I modify the formula so that it has absolute cell reference in cell J6. When I press command this, J7 should be absolute. Okay, so this is the formula. Just the first cell, J6, is the absolute cell reference. After that, I copy down the formula. Okay, and once I done this, no, this is not. So I should start with here, cumulative probability. The first one is this one, and the second one is the sum of previous two numbers. And then you modify the formula to add $sign for JS6. So after that, you copy down the formula. And again, you copy this number, copy, and again paste. Paste special, just paste the value. And again, add 0 here. All right, so we completed the bad weather, this table. Now, the weather condition. The question said the probability of bad weather is 0.2. That number is given, so you directly type in 0.2. We just have two possibilities, bad weather, good weather. So when bad weather is 0.2, good weather 0.8, there are complement events. Okay. And then this one is easy. So I directly type in the lower limit. This is 0, and this is 0.2. And the cumulative, this should be 0.2, and this should be 1. Okay. So I completed that part. Now, simulate 10 programs, 10 games, it is here. Produce random number. So type in equal rand, opening, closing bracket. And then use file handle to copy down. Next, we are going to see, based on this random number, we are going to see if it is good weather or bad weather. Okay. So we are going to use VLOOKUP function. Okay, so equal VLOOKUP. We are going to look up this random number. No. So we are going to, based on, see here, based on this weather table. Okay, so if the probability between 0.2 or between 0 and 0.2, it is bad weather. If the probability is 0.2 to 1, that is good weather. Okay, so maybe I'll highlight. So based on this table, how do you know it is good weather or bad weather? Based on the probability. Okay, so now we are going to use VLOOKUP equal VLOOKUP opening bracket. So look up one if this probability. Okay, and then table array is this table. Based on this table, we decide it is good weather or bad weather, and make sure it is absolute cell reference. If you're using Mark, Command T stand for toy. And if you are using PC, use F4 button, okay, to get the absolute cell reference. And then in this table, we are looking for column 3, because the first column is here. Lower limit is the first column. Cumulative probability, second column. The third column is give us the weather. So number 3 means the third column. Okay, so the first one we get good weather, and then you copy down the formula. So this is produced good weather, bad weather. Next, we are going to produce random number for cell. So typing equal RAND, and then copy down the formula. So now Once we get the random number for cells, okay, and we need to produce the cells. So how do we produce the cells? Again, we use VLOOKUP and also use if. So this step is the most complicated one. I try to go slow so that you can follow along. Okay. So this step, we need to say if it is good weather or bad weather. If it is good weather, we need to use this table. The good weather, we need to use this table to do what? To find cells, to find cells. And if it is bad weather, we need to use this table again to do what? To find the cells. Okay, so that is our objective. Use if to say if this one cell C17 is good weather. If it is good weather, if this is true, we are going to take a look at the good weather table. So we look up, look up. And we are going to look up at this random number, D17. And then this is the table array. We are going to look up good table. Command T to translate to absolute cell reference in Mark or iPad, Pro. And then column 3 means this cell's value is in column 3 of this table. And then it is true, means roughly match. So this is if it is good weather, we go to good weather table. If it is not good weather, then it must be bad weather. When it is bad weather, we look at bad weather table. So we look up, opening bracket, again, based on this random number, okay? And we are going to look up at bad weather table. It is here. This is bad weather table, okay? Absolute cell reference. And then the third column, the last parameter is true. So I pause for a moment so that you can understand this formula. So basically, when it is good weather, go to good weather table here. When it is bad weather, go to bad weather table here. To do what? To find the cells. Okay, so I found cells here. And then copy down the formula. The cost. Next one is the cost. The cost. Remember the number of cells or number of demand is in unit 100. Okay. The cells, so it is in E14. So this is number of program produced. Oops. I will use absolute self-reference because I want to copy down the form times. What is the cell? And this unit, you have to divide by 100 because I want to keep consistency for the unit. And then times cell price. This is the cost, so it should be times cost. So number of program times cost per unit. So this is the cost. Then you copy down the formula. So next, revenue. And remember, when you do the revenue, you need to figure out number of sales. And the number of sales is here. But if number of sales greater than 25, you are going to use 25. Why? Because we only printed 2,500. So we are going to use if function. If sales is smaller equal to 25, we use this sales number. Otherwise, we'll use 25. So this is the number of sales. Sales times sale price. That is a revenue. Number of sales times sale price. That is the revenue. So you got revenue. Copy down. And the profit is the difference between revenue and cost. So revenue minus cost is the profit. And then you copy down the formula. G minus F. So the average profit, which is just using average of this number. Be advised that the number you produced may be different from mine. The reason is we are using random number here. Your random number might be different from mine. Okay. So this is this question. And also we are asked to produce, to fill out this part, random number for bad weather. Okay. So first we generate the random number equal RAND. Then we produce 10 numbers. After that, we use lookup table to look up bad weather here. Equal V lookup. Lookup value is this random number. Lookup array, this table. Absolute cell reference using command T in Mark, F4 in PC. And then column 3, it is true. After that, copy down the formula. Right? So that is the simulation using Excel. Okay. In summary, this simulation uses Monte Carlo simulation to generate random number, and then use Excel VLOOKUP if function to produce the revenue, the profit. Thank you so much. See you next time.